Hello everyone, in this video we are going to learn elasticity and its applications. So here you have one scenario from your textbook. You maintain the social media accounts for local businesses. You charge $2,000 per business and currently maintain the social media accounts for 12 businesses per year. Your costs are rising, including the opportunity cost of your time. You consider raising the price to $2,500. The law of demand says that if you raise your price, you will not have as many accounts to maintain. So what does that mean? That means when the price is getting higher, customers are going to give up buying your product, your service. So the next question is, we know this relation, but the next question is how many fewer accounts you will have. So we want to know the amount now. How much will your revenue fall or might it increase? These are the questions we are going to answer in this chapter. What is elasticity? Elasticity is the measure of the responsiveness of quantity demanded or quantity supplied to a change in one of its determinants. So we want to know how responsive quantity demanded or quantity supplied to one of its determinants. The most important one that we learned in this class is the price elasticity of demand. What is price elasticity of demand? How much the quantity demanded of a good responds to a change in the price of that good. Loosely speaking, it measures the price sensitivity of buyers' demand. So we look at a series of examples in the following slides comparing two common goods. In each example, I want you to think about, suppose prices of both goods rise by 20%. Which good has the highest price elasticity of demand? That means which good is the most sensitive to a price change and why? And what lessons we learn about the determinants of price elasticity of demand. Let's start with the first example, Cheerios versus airfare. Let's assume prices of both of these goods rise by 20%. For which good does quantity demanded drop the most and why? Cheerios, as you know, has many close substitutes. If the price of Cheerios increases, you can buy Ruffles. You can buy some other products very similar to Cheerios. So buyers can easily switch if the price rises. Traveling by airplanes has no close substitutes. So a price increase would not affect demand very much. So if airplanes are increasing in price, you can maybe go by car, but if it's a far distance, it may not be optimal to drive far distances, right? So given this, when you think about availability of substitutes, if a good has more substitutes available, then that good's demand is price sensitive. So any small increases in price, you can substitute with another product. But if you don't have many substitutes, that means the demand for that product is actually not price sensitive. You continue. You may say that I'm not going to travel as much as before, but you still need to take the airfare, for instance, from one place to another if you consider the distance especially. So for that reason, airfare demand, quantity demanded for airfare is price inelastic compared to quantity demanded for Cheerios. Price elasticity is higher when close substitutes are available. Let's look at the second example, Mountain Dew versus soda. Prices of both of these goods rise by 20%. For which good does quantity demanded drop the most? Why? So for a narrowly defined good like Mountain Dew is one brand of soda. There are many substitutes. There are other brands in the market that you can substitute with. There are fewer substitutes available for broadly defined goods like soda, right? Soda is a big population. You can substitute the whole soda maybe with water or maybe with, I don't know, tea, coffee. But as you see, the elasticity, that means the responsiveness of quantity demanded to a price change is lower when we broadly define a good. For narrowly defined goods, there are many alternative brands. You can substitute one brand with another. So here is the lesson. Price elasticity is higher for narrowly defined goods than for broadly defined ones. Let's see this example. Insulin versus Rolex watches. Prices of both of these goods rise by 20%. For which good does quantity demanded drop the most and why? Insulin is a necessity to diabetics. A rise in price would cause little or no decrease in the quantity demanded because you need that pill for your illness. But Rolex watch is a luxury. If the price rises, some people will forego it, right? Even the rich people might say, I don't need it. So price elasticity is higher for luxuries than for necessities. Now let's see this example, gasoline, short run versus long run. The price of gasoline rises 20%. Does quantity demanded drop more in the short run or the long run and why? Let's see. There is not much people can do in the short run other than ride the bus or carpool. So in the short run, you can't do too many changes, right? You cannot buy an electric car or you cannot buy a hybrid car. But in the long run, you can make these changes. So people are more elastic. That means the quantity demanded for gasoline is more elastic in the long run compared to short run. In the long run, people can buy smaller cars or live closer to work. Price elasticity is higher in the long run. Now let's rank the following goods from most to least elastic so that we can understand. But before, you can just pause the video and do on your own to make sure that you understand what elasticity is. So we have in this list beef, salt, European vacation, steak, new Honda Accord and Dijon mustard. So we rank the goods from most to least elastic, and we know that salt should be the most elastic, right? Should be the last one, because instead of salt, what we can use? Maybe some spices, but still the salt doesn't have a good substitute. And the first one should be European vacation. Why? Because it's the luxury good. If European vacation becomes expensive, then you can maybe locally visit places, or you can just forego the European vacation for this year. So the most elastic is the most luxury one. And the second should be new Honda Accord. Why? It's because it's first of all that you can substitute with a used one, and also you can choose any type of Honda models. So for that reason, it has many substitutes. Therefore, the second is because the definition is very specific. The second one is new Honda Accord, and the third one is Dijon mustard. Again, you can find different types of mustards, right? It's narrowly defined. That's why we put the third one, Dijon mustard. And then the next one is steak. Why? Because steak can be substituted with other alternative beef. It's again narrowly defined. And the fifth one is beef. And the sixth one is salt. So the most elastic one, European vacation. The least elastic one is salt. So let's do some mathematical calculations to find out the price elasticity of demand. We can find the price elasticity as follows. Price elasticity of demand is percentage change in quantity demanded divided by percentage change in price. So percentage change in quantity is 15% and percentage change in price 10%, so we find 1.5. Along a demand curve, P and Q move in opposite directions, which would make price elasticity negative. So this is a fall, this should be negative. This is an increase, this should be positive. So the result should be always price elasticity of demand is negative. But for us, the magnitude is important. So take this in absolute value. So 1.5 is important to interpret this number. We can ignore the negative sign for price elasticity of demand. So we will drop the minus sign and report all price elasticities as positive numbers. So here on the screen, we have one example that we are going to use midpoint method, because in the previous slide, percentage change, delta means change, quantity is given. And percentage change in price is given as well. What if we are not given percentage change in quantity and percentage change in price? So we need to first calculate the numerator and then denominator, and then we will find the price elasticity. It is possible that you are only given 2 points on the demand curve. P1, Q1, when the price is $3, quantity demanded is 12. P2, Q2, when the price is $5, quantity demanded is 8. So let's find first the numerator, which in this case is percentage change in quantity. So this formula is, you have to know it. I mean, it's something that you have to memorize, but in the exams you can write it down on a piece of paper and keep it with you during the exam. So formula to find the numerator is percentage change in quantity divided by average quantity. If that is the case, change in quantity is Q2 minus Q1, because when the price increases from 3 to 5, quantity drops by 4, divided by average quantity. So let's do it. How we can find? 8 is Q2, Q1 is 12, and the average is 12 plus 8 over 2, minus 4 divided by 10, which is negative 0.4. Now the denominator has a similar formula too. This time percentage change in price, P2 minus P1 divided by average price. And how we can find? The P2 is 5, P1 is 3, 5 minus 3 divided by 3 plus 5 over 2, which is 0.5. So we find the numerator, we find the denominator. To complete this formula, we take the ratio. Remember, percentage change in quantity divided by percentage change in price. So elasticity is negative 0.4 divided by 0.5, negative 0.8. But remember, we don't care about the negative sign, so the elasticity is 0.8. So you have one example here that you can apply what you have learned. Price is given, two prices, 400 and 600. Quantities are given. So this is your P1, this is your P2, this is your Q1, and this is your Q2. And you are going to use the midpoint method to calculate percentage change in price, use the midpoint method to calculate percentage change in quantity, and finally take the ratio to calculate the price elasticity of demand. You can see the answers here, but I want you to pause this video and try on your own and then check the answers. So we know that now how to calculate price elasticity. We find the number 0.8 and we find the number 1.5. So what does that number mean? Demand is elastic if price elasticity of demand is greater than 1. Demand is inelastic if price elasticity of demand is less than 1. And demand has unit elastic if price elasticity of demand is equal to 1. We can understand the demand elasticity by just checking the curves. The price elasticity of demand is closely related to the slope of the demand curve. Rule of thumb, the flatter the curve, the bigger the elasticity. The steeper the curve, the smaller the elasticity. 5 different classifications of demand curves we have. The first one is a vertical demand curve. Look, if you change price by 10%, let's say prices fall by 10%, the quantity doesn't change, quantity stays the same. Therefore, this is an example of inelastic, perfectly inelastic curve. Consumers' price sensitivity is none. Whatever the price, they buy the same quantity. Elasticity is 0 means inelastic, perfectly inelastic demand. Let's see this example. It's a steep curve, right? It looks like letter I. Let's change the price. Let's say price falls by 10%. Look how much the quantity changes. Less than 10%. Just follow the arrows, the size of the arrows. Pink arrow is much bigger in terms of length than the green arrow. So percentage change in quantity is less than 10%. Percentage change in price is 10%. Demand curve is relatively steep. Consumers' price sensitivity relatively low, and elasticity is less than 1. So this is an inelastic demand. Let's look at the unit elastic demand. Price falls by 10%. Quantity demanded rises by 10%. So the elasticity is 1. Demand curve intermediate slope. Consumers' price sensitivity intermediate, and elasticity is equal to 1. Let's look at an elastic demand. As you see, demand curve is not flatter. It's not steep as the ones that we saw in the previous slides. We change the price again by 10%. Look, the size of the green arrow. The quantity rises more than 10%. So the result is going to be greater than 1. Demand curve is relatively flat. Consumers' price sensitivity relatively high. And elasticity is greater than 1. Perfectly elastic demand. In a perfectly elastic demand, the demand curve is horizontal at a certain price. Price changes by 0% and the quantity can change by any. You can choose any quantity, even the price doesn't change. For that reason, the elasticity is infinity, demand curve is horizontal, consumers' price sensitivity is extreme, elasticity is infinity. So you can see a few elasticities from the real world. Eggs, for instance, very inelastic. You don't have too many substitutes for eggs. Healthcare, the same. Cigarettes, people are addicted, so it's hard to replace cigarettes. Rice, housing, everybody needs a place to live. But look what beef elasticity is, 1.6. If beef is example, you can buy chicken, for instance. Peanut butter, there are other butters in the market. Restaurant meals is very elastic. Cheerios is very elastic. Mountain Dew, the same. So we go back to our scenario. You maintain the social media accounts for local businesses. You charge $2,000 per business and currently maintain social media accounts for 12 businesses per year. Your costs are rising, including the opportunity cost of your time. You consider raising the price to $2,500. The law of demand says that if you raise your price, you will not have as many accounts to maintain. So we said how many fewer accounts? We answered, we find the elasticity, maybe 10% fewer accounts. The next question is how much will your revenue fall or might it increase? Now we are going to answer this second question. So continuing our scenario, if you raise your price from 2,000 to 2,500, would your revenue rise or fall? Remember, total revenue is P times Q. A price increase has two effects on revenue. Higher revenue, because now you are selling at a higher price, but lower revenue at the same time because you maintain fewer accounts. That means lower quantity. And the next question is which of these two effects is bigger so that we can make a decision on total revenue. And it depends on the price elasticity of demand. For a price increase, if demand is elastic, that means elasticity is greater than 1. Percentage change in quantity, let's say percentage change in quantity is 15%, percentage change in price 10%, that means percentage change in quantity is higher than percentage change in price. The total revenue decreases. Remember, total revenue is P times Q, right? And the negative side, that means this quantity decreases more than the increase in price. Increase in price, let's say this is the size of the error, 10%, and decrease in quantity is higher, which is 15%. So the quantity dominates the results. For a price increase, if demand is inelastic, now again we are talking about price increase, in both cases price increase, this time quantity changes, let's say 5%, decreases when the price increases 10%. In that case, TR, remember TR is P times Q, and quantity decreases 5%, the negative effect, but the price increases 10%. The increase in price dominates in this equation, therefore total revenue increases. The fall in revenue from lower Q is less than the increase in revenue from higher P. So let's look at this example. Pharmacies raise the price of insulin by 10%. Thus total expenditure is equal to total revenue, okay, on insulin rises or falls. Remember, insulin, the quantity demanded for insulin is price inelastic. Okay, for that reason, a 10% increase in price for sure will decrease quantity, but maybe less, like 2%. So as you see, the negative side is much less compared to positive side, and we know that the multiplication is giving total revenue. Therefore, price change is going to dominate and total revenue is going to increase when the price increases. Let's look at B. As a result of a fair war, the price of a luxury cruise falls 20%. Does luxury cruise companies' total revenue rise or fall? So 20% fall in the price, this is the size of the error, will increase the quantity demanded more than the change in price, let's say 30%. Why? Because luxury cruises are very elastic. Therefore, the positive side dominates, right? Look at the size of the error. This size of the error is much more than the drop in price. Therefore, total revenue is going to rise. So price falls, total revenue rises in an elastic good. When you watch commercials, you see a lot of commercials on discounts on the cars, furnitures, fast food. Why? Because these are all elastic demand. Price elasticity of demand is greater than 1. By selling cheap, they sell more and they increase the total revenue. But you don't see discounts on insulin, right? The reason is simple, because you don't need to discount. People are consuming more or less the same when you increase the price. Therefore, when increasing the price, you are actually increasing the total revenue. So let's do this case study. Does drug interdiction increase or decrease drug-related crime? The first policy that we can follow is to increase the number of federal agents devoted to the war on drugs. If that happens, what is going to happen? There will be less people selling drug. Okay, let's say there is a demand and supply. This is supply for drugs in the streets, and there is demand and there is price and quantity. Because now federal agents are going to catch people, the supply is going to shift to the left, right? And because of that, the price of the drugs are going to increase. And if the price of the drugs are going to increase, remember, higher drug price, and this is inelastic. When the good is inelastic, total revenue increases. Total revenue is going to rise. And therefore, when there is more money into this crime, the more people are going to commit the crime, and that will increase the drug-related crime. The second policy is of drug education. By drug education, the idea is, okay, here is my supply, here is my demand. We want to actually decrease the demand. Is that going to solve the problem? Yes, it's much more efficient, right? Because the price of the illegal drugs is going to drop. When the price goes down, remember, this is an inelastic market, total revenue is going to go down. Therefore, it will reduce drug-related crime. The next topic we will talk about is other elasticities of demand, because we know that there are other determinants of demand, and one of them is income elasticity of demand. And income elasticity of demand measures how much the quantity demanded of a good responds to a change in consumer income. So what is it? It is actually here percentage change in quantity divided by percentage change in income. As you see, only the denominator is different. Instead of price, we put percentage change in income. For normal goods, income elasticity is greater than 0. So if here the sign is important, for normal goods, we find a positive income elasticity. That means when your income increases, you consume more of the good. For inferior goods, the reverse is true, because when you have more income, you spend less on bus rides, ramen noodles. Instead, you spend more on restaurant meals. So a negative income elasticity represents an inferior good. So here, one example, using the midpoint method at a price of 16, what is the income elasticity of demand when income rises from 5,000 to 10,000? So we are at the price of 16, okay? And income 5,000 is here, the quantity is here, and income 10,000, the quantity is here. So let's solve this question. First, we need to find percentage change in quantity. That means 12 minus 6 divided by 12 plus 6 over 2, right? The difference in quantity divided by average quantity. That is 6 over, this is 18 divided by 2, 9. 6 over 9, which is equal to 0.6667. So this is numerator. Okay, remember, income elasticity is percentage change in quantity divided by percentage change in income. And now we find this part. Let's find denominator. Denominator is percentage change in income, which is 10,000 minus 5,000 divided by average of income, which is going to be is equal to 5,000 divided by 7,500. That is equal to 0.0667. This is the denominator. Let's write it. Percentage change in quantity divided by percentage change in income. which is percentage change in quantity 0.667 divided by 0.0667, which is equal to 10. So this number is positive, therefore this good is normal, and it's greater than 1. That means this good is income elastic, very sensitive to changes in income. Its consumption is very sensitive to changes in income. Let's see this example. Assume that a 4% increase in income results in a 2% increase in the quantity demanded of a good. So remember, percentage change in quantity divided by percentage change in income. A 4% increase, so that is 4%, okay, here. In income results a 2% increase, 2% increase. Both are positive, which is 0.5. So it's positive, right? The result is positive because both are increase. If it's a fall, you have to change the sign. Positive, and the good is normal. Remember, if income elasticity is positive, it's a normal good. If it's negative, it's inferior. The next price elasticity we talk about is cross price elasticity of demand. Cross price elasticity of demand measures how much the quantity demanded of one good responds to a change in the price of another good. So how do we find percentage change in quantity in one good divided by percentage change in the price of the second good? So if cross price elasticity is positive, the goods are substitutes. If cross price elasticity is negative, the goods are complements. Let's see one example. Suppose that when the price of good falls from 10 to 8, the quantity demanded of good Y, so the quantity demanded for good Y, rises from 20 to 25 units. So Y1 or Q1, QY1 to QY2, 20 to 25. And the price of good X falls from 10, so that is PX1, falls to PX2, 8. So we need to find this percentage change in quantity demanded of good Y divided by percentage change in price of good X. So let's do first numerator, percentage change in quantity demanded for good Y, which is find the difference, divide by average of the quantities. 5 divided by 22.5, which is equal to 0.222. Let's find percentage change in price for good X, which in this case 8 minus 10 divided by average of these prices, right? Which is minus 2 divided by 9, that is negative 0.222. So we can find now this ratio, which is 0.222 divided by negative 0.222, which is negative 1. So here you see negative 1 says that these two goods are complements. Therefore, sign is important. If it's positive, they are substitutes, but if it's negative, they are complements. It's negative 1 and these two goods are complements is the right answer. The last elasticity that we talked today is the price elasticity of supply. Price elasticity of supply measures how much the quantity supplied of a good responds to a change in the price of the good. It's defined as percentage change in quantity supplied divided by percentage change in price. Loosely speaking, it measures seller's price sensitivity. P rises by 8%, quantity supply rises by 16%, so the price elasticity of supply is 2. Again, we use the midpoint method to compute the percentage changes. Supply is unit elastic, that means price elasticity of supply is equal to 1. And by the way, price elasticity of supply is always positive because of law of supply. Supply is elastic if price elasticity of supply is greater than 1. Supply is inelastic if price elasticity of supply is less than 1. Supply is perfectly inelastic, that means price elasticity of supply is equal to 0. Supply curve is vertical. This is supply curve. Supply is perfectly elastic, that means price elasticity of supply is infinity and supply curve is horizontal. Okay. The flatter the supply curve, the greater the price elasticity of supply. So what are the determinants of supply elasticity? Greater price elasticity of supply if the more easily sellers can change the quantity they produce. So there is an increase in price if the production can easily adjust to produce more. That means suppliers' supply, quantity supply is price elastic. Price elasticity of supply is greater in the long run than in the short run. In the long run, firms can build new factories or new firms may be able to enter to the market. Let's see one example. Assume the supply of parking spots is inelastic and the supply of wheat is elastic. Suppose population growth causes demand for both goods to double. For which product will P change the most? For which product will Q change the most? Draw a graph with the new equilibrium in the market for parking. Draw a graph with the new equilibrium in the market for wheat. So pause this video and think about the answers first, and then we will check the answers in the next slide. Here, first we say that let's draw like that. There is going to be here supply, but supply is going to be inelastic. That means it's like this, right? And this is the demand. This is for parking spots. And there's going to be P1 and Q1 in the market. And now because demand increases, let's say demand shifts to here. P2, okay, demand even increases that much. Look what happens. Because this good is inelastic, since the supply, quantity supplied is inelastic and the parking spots, you can't build new parking spots easily, right? What is going to happen when people are demanding more parking spots, then instead of building new parking spots, existing parking spots increases prices. So the price increase in the inelastic supply is going to be higher. So let's draw here the other one. This time supply is also flat, demand is like that, and supply, demand. Let's shift the demand curve to here. Look what happens. I want you to see the change in price. Look, this much, okay? So the price doesn't change that much compared to this much. If there is an increase in wheat demand, and if the supply is elastic, then definitely the wheat production is going to increase. Therefore, the price increase is not going to be as much as in the parking spot, because suppliers can adjust production. More supply to the market is going to change the price little compared to parking spots. And this is the summary. The price elasticity of demand measures how much the quantity demanded responds to changes in price. Is the percentage change in quantity demanded divided by the percentage change in price. Less than 1, it's inelastic. More than 1, it's an elastic demand. Demand tends to be more elastic if there are close substitutes, if the good is a luxury, if the market is narrowly defined, and if buyers have substantial time to react to price. Total revenue is P times Q, moves in the same direction as P if the demand is inelastic, moves in the opposite direction as P if the demand is elastic. And the income elasticity of demand measures how much the quantity demanded responds to a change in consumers' income. Cross price elasticity of demand measures how much the quantity demanded of one good responds to changes in the price of another good. The tools of supply and demand can be applied to many different kinds of markets. This chapter uses them to analyze the market for wheat, market for oil, and the market for illegal drugs. The price elasticity of supply measures how much the quantity supplied responds to changes in price. Is the price change in quantity supplied divided by the percentage change in price? Less than 1 inelastic supply, greater than 1 elastic supply. Depends on the time horizon under consideration. In most markets, supply is more elastic in the long run than in the short run.